welcome you to our science lesson for this week. This week, we are going to look at propagation or properties of light. We are still under light energy. We have not yet actually ended this, or we have not yet come to conclusions. So we are still under this topic. And today we want to look at propagation or properties of light. So the word propagation simply can also mean the properties of light. So what are some of the properties of light? We say light travels in a straight line. Of course, light travels in a straight line. As you can see here, we have here a source of light, and then we have the three cardboards. And then on the extreme end, we have the observer, or the person observing this light. So light can only move, or it can only travel in a straight line. So if you happen to disorganize these cardboards, light will not actually move or pass through and reach the observer. So if the observer wants to see the light, he has to arrange the three cardboards in one place, and then he will actually be able to see the light from the source. So we say the first property is light travels in a straight line. That's one property of light. The second one is light travels from a source to all directions. That light is able to travel from the source to all directions. Assuming I have the sun here, an object that can produce light, we have the sun, and this sun can produce its own light. So the light from the sun will actually move to all directions, as it is actually illustrated here on the whiteboard. So this is what it looks like, that light can move to all directions. So this is the source. The source can either be the torch, it can either be the sun, or the candle, any object that can produce light. So for me here, I used the sun. So the sun was able to produce light, and the light from the sun was actually in position to move to different directions. So we also want to continue and look at the rays. And the question is, what's a ray? A ray is a path taken by light. The path, that way light travels through, is what you call a ray. So a ray is a path taken by light. So light has got its path through which it moves. So we call it a ray. I repeat this one more time. A ray is a path taken by light, as it's actually illustrated here. So this is the path I'm talking about. So without this arrow, it means that's just a line which is drawn, a plain line. So you have to draw a line and then put an arrow to show that that's the ray of light traveling. Leaving that apart, we also want to look at beams of light. Before we look at the types of beams, we have to look at the definition. We have to get the meaning of a beam. What's a beam? A beam is a group of light. Is a group of light rays traveling in the same direction. The group of light rays traveling in the same direction. And we also have here the types of rays. Types of beams. What are the types of beams we know? We have the parallel beam, we have the divergent beam, and then the convergent beam. So what is the parallel beam? Parallel beam is a beam of light where rays from the source travel and do not meet. They travel and they don't meet. So they travel and in one direction but do not meet. What's divergent beam? A divergent beam of light is a beam where light from different directions meet at the same point. So the light rays move from different directions. The light rays move from different directions and then meet at the same point. Then we have what we call convergent beam. Before we look at this, we have first of all to look at parallel beam. We say this is where light from the source travel to the same direction but do not meet. They don't meet. These are parallel lines, but we can actually make them rays by putting the arrows, as it's actually drawn on the whiteboard here. Let's look at the parallel beam of light.
put a longer nail here. Kasumali mukongereko obuwanvu ngenda kuwandika.
Good. Let's continue and look at the other type of beam, which is divergent beam. To diverge, it means to spread or to scatter into different directions. So we say this is where light rays from the source spread to different directions. So I'm assuming that source of light is here. Maybe let me use the sun, and it produced its own light, and the light had to move into different directions. So we said this is where light rays from the source spread to different directions. That's what we call divergent. And I said the word divergent simply means to scatter or to spread into different directions. And an illustration is actually here, well drawn on the whiteboard. So the third beam of light is convergent beam. The word convergent means coming together from different directions or different places, and then you meet at at the same place or at one point. So convergent beam of light, this is where light rays move from different directions and meet at one point. They come from different directions and meet at one point, as it's actually drawn or well illustrated on the whiteboard. This is a light ray coming from a different direction. This is a light ray from a different direction. Then we have another ray, and then they meet at the same point. And what's the difference between convergent beam and a divergent beam? The difference is, with the divergent, the light rays move from one point to different directions. So each ray will take a different route or a different direction, but they were from one point. And then convergent beam, this is where rays from different directions come and meet at one point. That's what we call convergent. And the word convergent simply means coming together. So we want to look at effects of different materials on light. Effects of different materials on light. How do different materials affect light? One, we have the first material here. We call it transparent materials. And the question is, what are transparent materials? Transparent materials are materials that allow light to pass through them easily. Anything which is transparent is that object that can allow light to pass through it, and then light will not, of course, be obstructed. So we say these are materials that allow light to pass through them easily. So we have examples of transparent materials. One, we have clear glass, a clear glass like this one. We have here one of this one of the window. That glass is clear. Even you as a human being, you can actually see through that glass and see an object behind that glass. So we have the clear glass. That's one. Two, we have clear still water. Another word to mean still is stagnant. Water which is not in motion. Water which is not flowing. We call it still water. Clear still water. It has to be clear. The moment this water happens to have some impurities, that means it will not actually allow light to pass through it. So it has to have no impurity. And of course, when it does not have the impurities, automatically that water is clear. So we have clear still water, and it has to be stagnant, not flowing. This water can actually allow light to pass through it easily. Then we also have clear air, but remember we also have contaminated air. For this case, we want clear air because we were looking at the materials that can allow light to pass through them easily. Materials which can allow light to pass through them easily. I said clear air. So clear air, air which is not smoky, air which is not, of course, which is not contaminated, can allow light to pass through it easily. Then we have other objects which are called translucent objects or materials. What are these materials? We said these are materials which allow little light to pass through them. Translucent materials. These are materials that can allow little light to pass through them. They don't allow that much light, but they just allow a little. So we said these are objects or materials that allow little light to pass through them. So we want to also, okay, let's look at the examples of these materials that allow only very, very little light to pass through them. The first one is ground or broken glass. If you happen to break a glass, or you get a piece of glass and drop it down, and then it of course happens to do what? To develop those cracks. Automatically that glass will not allow light to pass through, much light to pass through it. It will allow little because of those cracks on it. Then we have colored glass. The glass which is tinted, either black or white, that colored glass there can't allow light, much light to pass through it. It allows very little light to pass through it because it is tinted or colored. Then we have oily paper. Oily paper. You get a piece of paper and then you apply some oil on it. It will actually make this paper not look transparent, but look translucent. And in that way, it will allow very little light to pass through it. So if you want a piece of paper to allow much light to pass through it, you should not apply oil on it, especially the polythene. You get that polythene paper which is transparent, and then you apply oil on it. It will actually allow very little light to pass through it. But if you happen not to apply oil, it will actually allow much light. So we say translucent materials. These are materials which allow little light to pass through them. And examples include ground or broken glass, colored glass, and then oily paper. Paper that has got some oil. We do not have only that, we also have other examples. You will allow me to clean off this part of the whiteboard and add for you those objects that allow little light to pass through them. So apart from oily paper, colored glass, and broken glass, we also have what you call smoky air. Smoky air. Leaving that apart, we also have what you call thin cloth. Thin cloth, including what you call tracing paper, and lastly, frosted glass. So these are the other objects or materials that allow little light to pass through them. We have smoky air, that the air which is actually containing or which has been contaminated with what you call smoke. So when actually smoke diffuses into the atmosphere, it of course finds air there and then it contaminates it, making it smoky or to have too much smoke. So we also have what you call thin cloth. The cloth which is actually thin. This cloth here, we have clothes which are heavy and those which are thin. An example of my cloth. My cloth is actually thin. It can only allow very little light to pass through it because it is thin, not heavy. Then you have tracing paper. You get a piece of paper and you apply some oil and maybe you want to trace something like a map of Uganda. That paper can allow very little light to pass through it. Then we have frosted glass. These are glasses people use like on the windows of bathrooms, especially for privacy. So these are glasses, we call them frosted glass. They allow very little light. Why? Because like if someone is like bathing, we do not want the people outside the bathroom to peep through and see them bathing or to see their nakedness. So we say, we use these frosted glasses in what you call windows of bathrooms, and also some people use them in windows of toilets, but actually we use them in the windows of bathrooms, such that when you go there to bathe, people outside the bathroom do not, of course, have that access of doing what? Of seeing you bathing. So leaving that apart, let's also look at the other objects. Call them opaque objects. Opaque objects. We say these are objects. These are objects which allow objects, which do not allow any light to pass through them. And examples include the following. One, look at these objects that allow which do not allow any light to pass through them. And here are the examples. One, actually, we can have a wall. We can also have what we call a block, if not a brick. We can also have what we call stones. Allow me to clean off this side or this part of the whiteboard, and I write these examples down. There are still more, leave alone this, we still have more. We have the human body. We have metals. We have a hard paper. Then we have wood, etc. There are a number of these. So what are opaque objects? We say these are objects which do not allow any light to pass through them. Of course, the word opaque means to obstruct light, making light not to pass through that object. The word opaque simply means to obstruct. So we say these are objects which do not allow any light to pass through them. And examples include a wall. We have a wall of a building. It cannot allow any light to pass through, even if you do it cannot allow. And then maybe if you create a hole, and that hole maybe is facing the source of light, the little light will pass through it. But if you don't create anything like a hole, nothing, of course, will happen. So we have a wall of a building. We have a block. You can also call it a brick. Then we have stones. We also have a human body. You can actually do what? If you want to prove me right, you can go and stand to the source of light and then face to a certain direction. You will actually realize that the light from the source will not pass through your body. And of course, be seen the other side. So, the human body is an opaque object. We have metals. Metals are also opaque objects. We have a hard paper, like this polythene, and also we have other papers. And then we have wood. Wood is also is also an example of an opaque object. So all these objects do not allow light to pass through them. And then these objects here, by the way, they form what we call shadows. How do they form shadows? Because they obstruct light. They don't allow any light to pass through them. Therefore, a shadow shall be formed. So let's leave that apart. Let's also look at other things. Let's look at effects of opaque objects in light. So we shall say they obstruct light and form shadows. They obstruct light and form shadows. So we say that all opaque objects, be it a human body, be it a metal, be it a hard paper, be it wood, we say these objects don't allow light to pass through them. So in that way, light shall be obstructed and later a shadow shall be seen. The shadow of that object shall be seen. So we say, what's the effect of opaque objects to light? They obstruct light and form shadows. And we are going to look at what a shadow is. So our next item here is what we call shadows. So let's look at shadows. Allow me to clean off here and write something. So let's look at shadows. And the question is, what is a shadow? So we shall say a shadow is a region of darkness. A shadow is a region of darkness caused by obstruction of light by an opaque object. So here we are. We want to look at the definition of a shadow. What's a shadow? A shadow is a region of darkness caused by obstruction of light by an opaque object. So what are the keywords here? One, we have to make sure that we underline the word darkness and then obstruction. So darkness, that part which does not have light, or the part that light didn't reach, or a part which is created due to obstruction of light or due to absence of light is what you call darkness. Then obstruction, of course, you blocking light, an object blocking light and making light not pass through it to reach the other side. Then, and of course, that's an opaque object. So we say a shadow is a region of darkness caused by obstruction of light by an object. So simply that's the meaning of the word shadow. I want to repeat this one more time. A shadow is a region of darkness caused by obstruction of light by an opaque object. So a question may come in an exam. What causes a shadow? Or how a shadow is formed? A shadow is formed when light is being obstructed by an opaque object. As simple as that. So let's continue and look at other things. Let's look at types of shadows. Let's look at parts of a shadow. Let's look at parts of a shadow. Parts of a shadow. So a shadow has got parts. A shadow has got parts. And we want to look at, we would like to know these parts. What are these parts? Question may come in an exam. Write down the two parts of a shadow. So the parts of the shadow include, we have Roman 1, we have the umbra. Then Roman 2, we have what we call penumbra. So basically these are the two parts of a shadow. We have what we call umbra and then penumbra. Of course with letter U, not A. So we have what we call umbra and then penumbra. So what's umbra? What's umbra? Umbra is the darker part of the shadow. Is the darker part of a shadow. I will actually draw this to show you what I really mean. So umbra is the darker part because you're comparing two things. Comparison, because I will say this is darker, not darkest. These are two things. Then what's umbra? What's penumbra? So we shall say penumbra is the lighter part of the shadow. Is the lighter part of a shadow. So basically, these are the two parts of a shadow. We have the umbra and penumbra. And here I've given actually the meaning of the two parts of a shadow. I began with the umbra, where I said umbra is the darker part of a shadow. The darker part. Of course, I'm comparing two things. I'm not supposed to say it's the darkest. Then penumbra is the lighter part of a shadow. The lighter part, meaning the part with some light, or the part with light. Then the darker part is that part without any light. And what caused this region of darkness is because of the absence of the light. There, light didn't reach at that part. So it created the umbra, which is the darker part, and then it created the penumbra, which is the lighter part. So if a human being happens to stand, let me say here, and then a source of light is behind me, I'm going to create the two parts. The one actually in front, it will be the darker part, which is the umbra, and then the one that will be created on the sides, it will be penumbra, because light will come and of course pass in this way. Try to dodge an object. So light will actually try to dodge me and create that region, which is the lighter part of the shadow. Let's call it penumbra. So let's look at how shadow is formed. How a shadow is formed. How a shadow is formed. How a shadow is formed? That's the question. A shadow can only be formed. A shadow can only be formed. A shadow is formed when light is blocked. In other words, you can say obstructed by an opaque object. I told you that objects which do not allow light to pass through them are called opaque objects. And objects that allow light to pass through, which allow light to pass through them, we call them transparent objects. And I give examples. And objects that allow little light to pass through them, we call them translucent objects. So how is a shadow formed? Because now here we are looking at shadows. A shadow can only be formed when light from the sun is being blocked or obstructed by an opaque object. So when that object doesn't, of course, allow light to penetrate, and then, of course, light to penetrate it, and then it reaches the other side. So we say a shadow is formed when light is blocked or obstructed by an opaque object. That's how a shadow is formed. Leave alone that, we also have something small to look at. To leave alone that, we also have other things to look at. Let's look at what we call reflection of light. Reflection of light. Reflection of light. Reflection of light. So the question goes to us, what's the reflection of light? Reflection of light is the bouncing of light rays. So this is what we mean by reflection of light. Reflection of light is the bouncing of light rays. So what does the word bouncing mean? That's the question. The word bouncing simply means light from the source meeting the glass. Of course, after meeting the glass, it will actually bounce back. So this is actually the glass. This is the plane mirror. This is a plane mirror. I'm assuming I have my plane mirror here. Plane mirror. And this plane mirror, it has the part which is actually shaded or tinted or colored. Then this part is a fine part. This is actually shaded, this is a fine part. So when the ray from the sun or from any source happens to meet this fine part of the mirror, it will actually bounce back and form another ray. So, after forming another ray, there shall be a line that will separate these two rays. So how are we going to call this ray? The ray of light that hit the mirror, we shall call it incident ray. It hit the mirror. I don't mean hit with the E, I mean hit with the I. To hit something. And then how do we call this ray that bounced? We shall call it reflected ray. That ray was reflected. We shall call it reflected ray. We have a ray from the source of light. And that ray had to meet the plane mirror. The fine part of it, the part which was exposed into sunlight. So that ray, it's the only ray that hits the mirror to create the other ray. After hitting the mirror, the plane mirror, it created another ray which is called reflected ray. Now this ray was reflected. So that's why I say reflection is a bouncing of light rays, a bouncing to a reflected back. But in between, there is a line which is separating the two rays. We have the reflected ray on my left, then on my right, we have the incident. How do we call that ray? This line here, we call it a perpendicular ray. Or we shall call it the perpendicular line. So, simply this is what I wanted to show you. We said reflection is a bouncing of light rays. And how will I know that light bounced or the ray bounced? This is an illustration. Here we have the plane mirror. The part which is actually below is shaded. Then the other part above is the fine part. So when the ray from any source meets this fine part, it will actually be reflected or it will bounce back. And then we shall actually have a line that will separate these two rays. So that's actually the meaning of what we call reflection, is a bouncing of light rays. And you want now to look at the meaning of this ray. We have the reflected ray, we do not know its meaning. Then we have the incident ray. So the question is, what is incident ray? What's an incident ray? What is an incident ray? So we are going to say, this is a ray that hits the surface of a plane mirror. So you say, this is a ray that hits the surface of a plane mirror. But what part of the plane mirror did it hit? It's actually the fine part, the part which is not colored. It's the one that the incident ray hit to create the other ray which is called the reflected ray. So we say the incident ray is the ray that hits the surface of a plane mirror. So let's also look at the meaning of what we call the incident ray. Let's look at the meaning of the incident ray, of the reflected ray. So we say reflected ray is a ray this is a ray that bounces off the surface of the plane mirror. As simple as this. What is a reflected ray? We say this is a ray that bounces off, which is reflected or that goes back. This is a ray that bounces off. Of course, double F. I don't mean the other off with a single. That bounces off the surface of the plane mirror. It's a ray that goes back after the incident ray hitting the plane mirror, the surface of the plane mirror, then the reflected ray is created. So that's why I say the reflected ray is a ray that bounces off the surface of the plane mirror. So we also have the other part. We also have the other ray. We call it the normal line. We have that other part, or that line that separates the two rays, and that line is called the normal line. And that line is a line which is it? We say this is a line which is perpendicular between the incident ray and the reflected, and the reflected ray. So we have the other ray. We call it the normal line. It's actually the one in between the two rays, the one in the middle. We call it the normal line. And how do we define it? Say this is a line which is perpendicular, between the incident and the reflected ray. The one which is in between, the one that separates the two, the one which is in between, we call it the normal line. It can be actually written in, you can draw it in broken, when it's broken, or you can actually get your ruler and draw it when it's actually plain. Or you can actually break it, or you can actually draw a line which is plain. So we call it a normal line. Say this is a line which is perpendicular between the incident and the reflected ray. That's the line which is between the two rays. So leaving that apart, we also have some other items to look at. Let's first have a diagram here, an illustration to show reflection of light. So we are going to have an illustration. I'm going to draw my plane mirror here. Sorry. And then shade it, or color the other parts, or tint it. And then draw the incident ray. Of course, that's the first ray which is drawn. That's the ray that hits what you call the surface of the plane mirror. So it's actually the first to be drawn. Then draw the other ray, which is reflected with the ray that bounced off the surface of the plane mirror. You shall actually draw it there. With the arrows, to show, what do we put the arrows there? Those arrows show that these are rays. These are rays. So a ray must have an arrow. You draw a line, and of course you include an arrow. When you draw a line which is plain, that's just a line. So we have to draw a line and put an arrow. So in between, I'm going to have my broken line, which is the normal. Which is the normal. So what is on my left? Which ray is that one? We call it incident ray. And what ray is on my left, my right? We call it the reflected ray. And then in the middle here, we shall have the normal line. It is perpendicular. This line is perpendicular. We shall have the normal line. Shall have the normal line. Normal line. Then this line, it makes these rays to create angles. Shall have angles here. Just mention this. So we have this angle A, and then angle B. So angle A, it will be called angle of incidence. What about angle B? Angle B, we shall call it angle of reflection. Angle of reflection. So we have angle of incidence and angle of reflection. Angle A is angle of incidence. Then angle B is angle of reflection. So these are the two angles we can find here. And with this, I would like to end here, and thank you very much. See you next time. I'll continue from where I've just ended. I'm called KATONGOLE, ATANAS.